For today's lesson, our focus standard continues to be from grade 7, Expressions and Equations, Standard A, Use Properties of Operations to Generate Equivalent Expressions. Our topic for this video comes from our Simplifying Expressions and Equations unit, Substitutions with Expressions. Our essential question is, how do we evaluate expressions with substitution? Please take a moment, pausing the video if you need to copy the topic and the essential question in your header along with today's date. Save your question column and your note column and resume the video when you're ready to begin. So here are some common instructions that we will see throughout algebra units where they say evaluate each expression below for the given values. Evaluate, we've talked about before, really just means to solve. And so they're going to give us some values for the expression, for the variables in the expression, and we are to evaluate and solve and continue to simplify it down to one value. So let's go ahead and try our first example. So in example 1, we're being given the expression 3m subtract n squared, or m equals negative 8 and n equals negative 5. So we're being asked to simplify and evaluate this expression if we substitute, or in other words, plug in the values negative 8 everywhere we see m and negative 5 for the variable n in this expression. So we're going to treat this as a problem out of a textbook or off a worksheet or something, and so the first step is always to copy down the expression again into your work. So here I have it, 3m subtract n squared. And then we're going to write it again, now substituting in these values for the variables using parentheses to note that we've substituted in those values. So our expression now looks like 3 times the quantity negative 8 subtract negative 5 squared. So as soon as you do the substitution, it becomes an order of operations problem. So we have to remember our work from PEMDAS. And it tells us parentheses. Well, each set of parentheses only has the value that we've substituted in, and then exponents. So we'd have to do this negative 5 squared as our first calculation and take it from there. I'm going to actually allow you to pause the video here, see if you can simplify it as far as you can down to one value, and then we'll compare our work to see how we did. Let's see how you did. So when I squared negative 5, I got 25. I kept the subtraction. Negative 5 times itself is 25. Then I did my multiplication of 3 times negative 8, got a negative 24. So I now have negative 24, subtract 25, and the final value is negative 49. Let's try another one. For example 2, we have 2 times the quantity 3x plus 4, subtract 2x, if x equals negative 9. So we're being able to evaluate this expression if x equals 9. Well, following the steps from above in example 1, we'd start by copying down the expression. Right, so 2 times the quantity, 3x plus 4, subtract 2x, and then use parentheses to show where we are substituting negative 9 into the expression. And now it becomes an order of operations problem. So there aren't any exponents, but there is some parentheses with now values that can be simplified down to one value, right? 3 times negative 9 is going to give us a negative 27. And we keep the add 4, kept everything else as it was, just bringing it down, following order of operations. So then if we take negative 27 and we add 4, we get negative 23. So our expression at this point is 2 times the quantity negative 23, subtract 2 times negative 9. Go ahead and see if you can complete this expression and finish evaluating it all down to one value. How'd you do? When I finished simplifying it, I got all the way down to -28. With this example, I'd like to show you one other possibility. So if we go back to our work on simplifying expressions, before we gave us any values for the variables and I would have just given you the expression 2 times the quantity 3x plus 4, subtract 2x, you would have been able to use the distributive property and combining like terms to simplify that expression. And here I have that written down here because that's exactly what I want you to do. What would you get if you took this expression, 2 times the quantity 3x plus 4, subtract 2x, just keeping x as it is, using the distributive property and combining like terms, what would you get if you simplified this all down? Go ahead and pause the video now to do that work, and resume the video to check your work with mine. Well, it should simplify all down to 4x plus 8. So in problems like this, you could, as we practiced with the first 2 examples, copy them down as is. Everywhere you see the variable, substitute in the value, and then use our order of operations to calculate this down. And we did that right here, getting -28. But we could also go ahead and use our skills of distributive property and combining like terms to first simplify this expression to its simplest form, as in here, 4x plus 8. And that would then allow us to use 4x plus 8, plug in our value of -9 for x, and in 2 steps, calculate the work. If we are to do that, 4 times -9 is -36. -36 plus 8 simplifies down to -28. So now we have 2 methods where we can now prove that this expression is equivalent to this expression, because if we plug -9 in, we get the same value. It also gives us a way to check our work. So if we substitute -9 into the original expression, we should get the same answer if we simplify that expression, plug in -9. So a couple of options here with these types of problems where we can use the distributive property and combining like terms to simplify the expression. Let's try one more. Here's our example 3. We're being asked to find the perimeter of the shape if y equals 4. So we have a triangle, and we're being shown that this side, this top edge, has the value or the measurement of 5 times y, subtract 3. This other long edge on the bottom side of this triangle has the value or the measurement of 1/2 times the quantity y plus 11. And then we have the short edge, which has a value of just y. So we're being asked to find the perimeter if y equals 4. So again, perimeter means the distance all the way around the outside of a shape. And we can use what we talked about in example 2, where we can first start by finding the perimeter as it's given to us. So I could write it out like this. The perimeter equals this side, 5y subtract 3, plus this other long side, 1/2 times quantity y plus 11, plus the third side, right, adding all the sides together, which has a value of y. So I could write it out like this, substitute in 4, and calculate it down. Or I could simplify this expression by using the distributive property and combining like terms, and then plug in 4. So I'm going to let you choose your method and pause the video here to do your calculations, and then we'll resume the video to compare our work on this third and final example. So I'm going to go ahead and reveal all of my work here. So in each step I've plugged in the value of 4, and then I've used order of operations. I got a perimeter of 28.5 units. However, I also looked at this expression and said, well, it could be simplified down to the value of 6.5y plus 2.5. Then I substituted in 4 for y and came to that same answer, that the perimeter of this triangle, if y equals 4, would be 28.5 units. So it's important to realize that you have both options here. Also nice to use both options as a way to check your work. That's going to conclude our video for today on substitution with expressions.